Conditionals. What is a conditional? Yeah, it's an if-else statement. It means if something is true, then do this in code. The thing is, when you as the developer write code, you can't anticipate every possible scenario, right? Like you can't write code one way for some people and another way for other people, right? So like maybe we want your code to act differently if the person using your program is, let's say, 18 or older, or they're younger than 18, or they're or they length I don't know. You can't obviously change your code after you've written it to work for different people. So a conditional allows us to say, well, if this is the case, then run this code. If this is the case, run this other code. And in all other instances, okay? That's the idea of a condition. So conditional lets you run different scenarios in different instances. Can you think of a way or a time in just regular life, not coding related, that you basically do the process is conditional?
If I run down the path on the left, it's kind of dark. It sounds like you kidnapped me. If I go down the path on the right, I do see some wild dogs, so I could get attacked.
Yeah. There's no good scenario. So you're not a Robert Frost path west. Bad. Yeah. So like if I go this way, this might happen. If I go this way, this might happen. Or this will happen, and that will happen. And if I jump into
Else just stay where you're at.
Or like if I wake up late, then I do like skip breakfast and a shower or something and just head straight to school. If I wake up early, then I can also do this. Yeah, regular conditions. I mean, every single decision you make is essentially be conditional. Okay. The syntax. Ooh, that's bad. Okay. The syntax is always in the if statement. Okay. In JavaScript, it's just word followed by parentheses, followed by curly braces. Inside the parentheses, you put the condition, and inside the curly braces, you put the code to run. Okay. The condition will always need to evaluate to a Boolean. What's a Boolean again?
True, false statement.
It will need to, the computer will need to be able to turn it into a Boolean somehow. Okay. So if I put true, and then let's say the code that I run is a console log. What's the code to happen?
Wait, no. Yeah, it's not doing it all.
Oh, it'll just log high.
In every single circumstance, it will run this console. There's no chance that it will not run this console log. I'm going to move this onto its own line, just so it's more easy to read. Because I've hard-coded a true value, when the condition evaluates true, it will run the code in here. And we can see that right there. There's my console log hi, or I'll just run it node. Okay, it says hi. If the thing in the condition evaluates to false, it will not run the code in there. Let me clear this out. Okay, notice it just didn't even console log anything. And that's because they've hard-coded a false. Okay, so this is, you'll never do this. Okay, there's no reason to write anything hard-coded false, just like delete that code, right? There's no reason. computer will skip right over. And similarly, true, there's no reason to say if true, do this. Because you might as well just get rid of your if statement and say, I for sure want a console log to show up, right? So you won't hard code in there unless maybe you're debugging. It's like, I'm just going to say if true to see if for some reason like this code decided to do something weird. But usually you'll have some kind of expression inside of there. So if I were to say if the number 1 equals the number 1, okay, what does the triple equals do?
Privacy triggered by type as well.
Yeah, it's a comparison. It says is the thing on the left the same as the thing on the right? Yeah. Yep. This is equivalent to me saying if true, right? There's no reason for me to say if 1 equals 1. But usually one of these would be a variable that could change. So I might say if number equals 1, and above it I might say number equals 2. Right? This is a variable, so the number can change. Or let's pretend that I'm asking the user to input a number, and then I'm saying if number equals 1, I know what that is. So I can say if they typed in 1, you put it in 1, or if the code previous prior to this if statement evaluated or figured out a way to make number 1 map to 1. I don't know. So in this instance, will this code run?
Right.
Will I get a console log? Why not?
Because it's false.
Right? Then number 2 is not equal to 1, and therefore it will not run. What if instead of saying 2 is saying exclamation point? It will run. This means does not equal, and it is true that 2 does not equal 1. You could think of the, so what the computer does is it evaluates everything down to a Boolean, and so it says, well, number is 2. 2 does not equal 1. Is that true? Yeah, that's true. 2 does not equal 1. So it says, okay, this is true, or it runs the code. Sometimes when you have a complex condition in there, I like to run through like the computer. I try to pretend to be the computer and reason about it. Same thing. And I'll actually change the code. I'll be like, number equals 2. That's 2. Is this a true statement? That's what I'll ask myself. Is this a true statement? Yes, it's a true statement. 2 does not equal 1. True. Okay, the code will run. Right. Okay. What about? Let me catch up here. Greater than or less than. These are hopefully obvious math classes in like elementary school or middle school. Again, ask yourself, is this a true statement? Okay, because 2 is not less than 1, therefore it's false, and it won't run. So when I do this, it doesn't run my console log high. Now, what if I do want, so notice that just like nothing is happening, right? I hit enter and just says, okay, I'm done. What if I want something to run? Let's change this from high to condition is true. What if I wanted to say the condition is false if the condition is false? What an else? Yeah. So what does else do? If takes an argument here inside of parentheses that evaluates this kind of condition. How come else doesn't?
It's everything else.
It's everything else. In every other condition, run this. Okay, so I might have condition is false. So now at least I'll get something showing up. Which one's gonna show up here? False, right? Good. Okay. So that's if else. Else only came after if. Convention is to put it on the same line as the closing curly brace. If that's not a determining factor of it working. Okay, it will still work, but this looks weird to JavaScript developers. So just put it on the same line. Let's go back to the triple equals. And what if I want to check? What if I want to do something that number is 1? I also want to do something specific number is 2, and I want to do something different for any other numbers.
If, else.
Okay. Technically, I could put an if statement nested inside of here or something weird, but I can also do chain together. You do an else if. Okay. What's wrong with this code? Yeah, it needs to evaluate something, right? Because there's an if, I need my parentheses and something to evaluate. Else doesn't do that because it's every other condition, but else if says else if what's true. So I put my parentheses back in. I say number is 2. Let's change this to number is 1. Number is 2. I kind of jumped the gun. And then you chain your else on the end. Your else will always be the last in the list. So it wouldn't make sense for me to say else do this, else if do this other thing. Just like when it's in real life, you're talking about this or I don't know, that's not a great example, but you know, like you don't want to put your else somewhere stuck in the middle of your condition. So also I'll repeat the end. So then in every other instance,
if you can't do this, you gotta do this. Or if you want to, you can just do it.
It's not 1, it's not 2. No, it's not 1 or 2. Oh, crap. But that's pretty much all this program can know, right? So I get the number is 2 because number is 2. The way the computer thought about it was it said, it started here, it said if, okay, I'm evaluating the condition, and then it evaluated the number, and that evaluates to what? The computer looks at this statement and it evaluates it to false. Yeah, it sticks 2 into the number, and then it evaluates 2 triply 1. Nope, it's false. So it evaluates it to false, and it just totally skips this, everything between the curly braces of this if. I don't care about that because it's not true if the condition is false. And then it says, oh, here's another condition I need to check. And then what does it evaluate this to?
True.
True. Yeah, it's 2 in the number. It says 2 triplet is 2. It says that is a true statement. So I need to run this code. Okay? And so it runs the number is 2, which is why we got the numbers 2 down here. And then what does it do for the else? Yeah, only one of these instances will ever be run. And so as soon as that one that it runs, like maybe I have this like 100,000 chain else ifs, 100,000 else if, it finds one that works and it just goes all the way to the bottom and just skips everything else. Okay? It doesn't care because it's all part of one chain and one and it just ran to one. Make sense? Cool. let's do a more practical example. Did any of you venture into prompt, using prompt in your pre-course project? This is one of those things that,
Like alert.
This is one of these things that only works in DOM JavaScript in the browser. Prompt doesn't make sense in Node. Same with alert. Yeah, alert only works in the browser. It doesn't work in Node. But it's a really easy way for me to gather information from a person. I'm gonna turn off the autosave right now because it's gonna keep prompting me. Or maybe I'll do this. Actually, let's. Okay, maybe this would be less enraging. Oh, no, that's super annoying. It like puts my focus over here instead. Yeah, we need to turn off autosave. What are my options here? False, maybe? I don't like that. Off, string off. Okay, don't do that because autosave's really nice, but since this is prompting me and moving my cursor over here every time, it's obnoxious. Okay, this is still obviously pretty contrived, but it's a little more realistic because before I was hard coding number. Does it Let's say I'm actually going to prompt people what their age is. I'm going to save this in a variable called age. So now I really don't know what age is going to be. Okay, what if I want to console log? I think I don't want to steal one of your exercises. What's something that can say drink? Okay, you need to be 21 or older to drink. So let's say I want to console log, you are allowed to drink or you are not allowed to drink. What is, actually, console log, one person, Brave, Carlos. Okay, tell me what I need to type to determine whether it should console log, you're allowed to drink, you're not allowed to drink.
All right, start age. Age.
Okay, I'm gonna be literal. What's up? I'm gonna be literal when you talk to me. So.
Fair enough. Open parentheses. There we go. Age. Less than 20. I guess. Open curly bracket. Are we doing the output right? Well, yeah, console log.
Okay.
And type your adult drink. Or, I guess you want to do
Yeah.
the age as well.
Oh, we'll get there later. Yeah. Good enough.
Right. And then bottom, type L. Open the curly bracket. Console.log, bring it up.
Already on.
Except for the picture.
Okay, so now here's something to notice. As soon as I saved this immediately refreshed, and the very first thing it did was prompt me. This isn't inside of any function that only runs after like someone clicks something. So what's our age?
132.
Let's say 17. You're not allowed to drink. Okay. I'll refresh the page so it prompts again. 20.
There was a mistake.
Yeah.
Ah,
You gotta put less than or equal to.
we're promoting underage drinking here.
Less than or equal to.
Yeah.
Yeah.
Yeah. Yeah, so I could either say less than 21. I think it makes a little more sense,
You could do that too,
but they literally work the same, unless you are going to have decimals, I guess. Why is that fat? Okay, so yeah, if we're 22, drink up. If we're 20,
They can test it with the nose.
oh, I need to save it. I turned off autosave. Okay, for 20, I'm not allowed to drink. I don't know why one is doing that. One of them is throwing the favicon and the other isn't. Oh, maybe it's to do with this.
Yeah, picture throws it off.
Oh yeah, that's funny. It's reading the emoji as a favicon, which is the little icon that shows up at the top of your browser in the tab, like to the left of your title. That's funny. Cool. Okay. Does anyone have questions on this?
He's logging it. It was showing up. It's like one of these, like the little picture less next to your title.
You're less than 21 or you're not less than 21.
That emoji.
How come I don't use an else if age is greater than or equal to 21?
Because there's only 2 options.
Why would I waste my time, right? This will work. It's just pointless. There's only 2 options.
Unless you're standing in the doorway ready to turn 21.
You're still like a gorilla.
Yeah.
Yeah, I don't know. Yeah. Now, what would be wrong with this though? This is something to kind of a gotcha. Actually, what would it do? Yeah, it won't run
You do
anything.
one like a else.
It'll basically say, nope, okay, keep running code below there.
Like cigarettes, but you can't drink it.
It's not infinite. It's not elite. Cool. All right. Oh, okay. Here's another tricky thing.
Right? Time. Oh, time. Yeah, 12.
Okay, we'll get rid of our prompt. If
I think that really. Sure. Whoa.
and
Whatever.
I'm gonna get rid of this, so let's give away the answer. Okay. Okay. Who thinks that this will console log weird? Who thinks this will console log? Whoa. And 16 of you did not answer.
Oh, so those are the only 2 options? I thought it was a trick one.
If it is less than 2 options.
I guess the last or the first one.
Yeah, it'll be wall. It'll be wall.
Sound like you're trying to convince yourself.
Oh, no.
Yeah. It's 12.
Whoa.
It's weird. It's not weird. It's 12. Why?
Basically, there's sort of Boolean interpretations of the Dallas replays for certain parameters for well, same place for conditionals.
Yeah.
So in this case, since, I mean, it's more accurate to say that there's some conditions that the JavaScript is going to assume they're false, even though they're not booleans, and everything else that doesn't fall in there is going to be true.
Yeah.
And strings basically don't fall into those. So we should, like, for example, 0 is going to be interpreted as false, and undefined.
Yep.
Stuff like that.
Yeah, so we call those value.
I got my
False value. What's that? You double false. Oh,
like with math, a double negative.
so you're talking about like exclamation point, false, like not true. Yeah, we'll get to the we'll get to those in a second. But so there's true C values and false C values, and because the computer needs to determine if it's true or false. Up until now, we've been talking about things that the computer can literally turn into a Boolean, right? 1 plus 1 always turns into a Boolean. There's no way for the computer to simplify further string. It's and so when it comes to truthy and falsy, it's important to know what the falsy values are.
Can't see.
And let's go with this. Okay, so the following are all falsy values. False, obviously. 0.
Undefined.
Empty string. Undefined.
Number.
Oh, and NaN, not a number. These values are all considered falsy. So if I were to change this string hello to an empty string, which one now is to weird? No, I have to save it because I turn off autosave. Let's go ahead and turn that back on. Shoot, what did it used to be? Yeah, but I don't think it had a delay. I thought I clicked here before and it gave me all the options. Oh well. After delay, and then I think I need to specify, or maybe it's got a default delay. Yeah, it's probably got a default delay. Okay, so if empty string, I get weird, right? I get the one that's false. It considers an empty string falsy. And the same thing is going to be true, just like it was a false of 0. It's going to be true of not number. Okay, so it's weird, undefined, and so forth. So it's easier to remember these false values, and everything else is considered a true value. Okay? Any string of certain length or a number that is not 0.
Are these values that you can very used to, like there's an error or something that's something like wasn't, like if you have a value that wasn't defined at some point?
Yeah. So yeah, sometimes you won't know if you're doing it. You might do it to check something is defined or undefined, so that you don't crash your program. That's a common practice. Yeah. We'll definitely run into that. And so you can do an if statement around it there. So what if I do this? Do you guys know what the string.length does? Yeah, how many characters are in that string? Okay, what's this going to? Yeah, it's going to be 12. Because so the computer gets to the if statement, it evaluates what's in here, and what does it evaluate in that length? 3, which is not 0, and therefore 3 is a truthy value, and so it runs the stuff in the if. Okay. What about this? What is that in there? We need to zoom in a little. Okay, who thinks this will do whoa? Just own it. Be confident. I want everyone to vote. Who thinks this will do whoa? Who thinks this will do weird?
Weird.
Whoa. Okay, remember, these are your falsy values. If it's not one of these, which this empty array is not, it will consider it a truthy value. The same will be of an empty object. But what if I did, this? It's false. Because my array's length is 0, and so my array.length evaluates to 0, and that is one of your falsy values. Okay, so anyway, remember, these are your falsy values. Anything else will evaluate to true. Okay. Okay, we have 9 more minutes before lunch. I want to cover the logic operators really quick, and then we'll do lunch. Sometimes it's important to evaluate multiple conditions at once. What if, all my examples are like super contrived. That's okay. Let's say we have an age that's 13. Actually, this might work. I think you're going to have one of these. All right. Let's say we want to, let's say this is again super contrived. We're a movie theater and we want to check if our user, someone coming in to buy a ticket on our website maybe, is allowed to buy that kind of ticket, okay? And we'll say that there's a PG, PG-13 and R rating movies, just for the sake of argument here. Okay, so we know that there's going to be a variable age, and we know that there's going to be a movie rating. And actually, you know what? Let's do these as prompts, just so it's a little more obvious. What is your age? And what is the movie rating? Okay. So we're actually gonna ask the user what's the, and I have to turn off autosave. Okay, so we're gonna ask the user what their age is and what the rating of movie that they're gonna see is. So what's some logic that I can do to check if they're allowed to be in that movie? Well, I now have 2 things that I need to check, right? So if I have an if statement, I can't just say if your age is greater than 13, you're allowed to be in this movie, right? Because if it's an R-rated movie, they're not. What's the age for R? Is it 17? 17? 17 or older, like you don't need ID or parent or whatever. Parent, you'd need ID. You would need a parent to go with you. So I guess I could start out by just saying, if your age is greater than or equal to 17, what? All access. Okay, because right at the beginning I can say it doesn't matter what the movie is rated. If you're 17 or older, I don't care. You're allowed in. Okay. Okay. Else if what? What's something that I could put here to like add some logic to our check, our system?
Less than 13. And
Okay. Two ampersands. Two ampersands means both of these conditions need to be true in order for the code inside this block to run. That's what and is saying. And it's just like in English. Like if this is true and this is true, then do the following thing, right? If I wake up late for class and it's a weekday when class is being held, I need to rush to class. But if one of those is false, if I wake up late and it's a Saturday, well, I don't need to rush to class, right? There's no class. So with the and, both sides need to be true in order for the whole thing to evaluate to true. And actually, let me write a note on that real quick. So we'll have. I don't want that there. The and operator, both sides need to be true for the whole to be true. So let me make this even smaller here. So if I have, the computer's going to see both sides on this logic, this double ampersand, the and operator. It's going to evaluate both sides and determine if the whole thing is true. So if let's say I wrote if true and, actually let's start here. If I do if false and false, what's the computer going to evaluate the false and false to? False. Okay, remember it's trying to boil everything down into a single Boolean. And so this is the way that it's going to do that. So false and false evaluates to false. False and true evaluates to what? False. False. But what about true and false? Also false. The only one that works with the ampersands, the and, is true and true, right? So up here, age is less than 13 and what? I mean, there's a ton of different ways we could organize this, but any one is fine, like whatever we come up with right now. Yeah, sure. This doesn't need to be like the most concise thing ever. So if the age is less than 13 and the movie is a PG-13, what's something we might want to say? Access denied. Okay, and again, this isn't necessarily the most concise way we can do this, but somebody else using the and operator, somebody else come up with a check that we might want to do.
That's only greater than 13 and less than 17.
Okay, so if age is greater than 13?
Or if it's greater than 6.
Greater or equal. Yeah, greater or equal to.
Okay, so if they are 13 or greater, and then what did you say? And?
Age is less than 17. Yeah, age is less than 17.
Age is less than 17. Maybe another and?
Yeah, great. It's PG-13 side R.
Okay.
like
Okay, now how could I simplify this? Just logically speaking, this is correct, and it is okay to have multiple ampersands, or rather multiple and operators. It's simply going to start on the left and start evaluating things on the right. So it's going to check, is age less than or equal to 13? Maybe that's, or sorry, greater than, but maybe that's true. And then it'll say age is less than 17. Maybe that's true as well. It's going to take these and it's going to say, well, that's true, just to simplify it. And now it only has two arguments. And it's going to say true and movie rating equals R. Well, maybe that's true. And then that's going to evaluate down to true. Remember, the computer wants to boil everything down to a single Boolean. So that's the process that it's going to take. And it gets complicated with order of operations, like and has a higher precedence than or and so forth. And I think the not operator is the most important, and then triple equals is, anyway, it can get complicated, but that's the idea. Yeah, Hannah.
Do we need the statement about age being less than 17 though? Because anyone that's over
Great.
17 or older is going to be called the first statement.
Great. So
Yeah.
that's something else to think about. Remember, in this if else, we're only going to run one of them, and it's going to start at the top and work its way down. So in our case, well, here we're checking if they're greater than or equal to 17. But in our, like, logically thinking, if the movie rating is R, we don't care if they're greater than 13, right? It's simply if they're less than 17, and the movie is an R movie, then they're not allowed. But that's beside the point. We're not trying to actually make the system work. What's wrong here? Oh, thanks. Everyone's like, Bob, you told us we can't have an else with the condition. Any questions about the and operator? Let's cover or really quickly and then we'll be done, okay? Or is two pipes. These are pipe characters. You hit shift and you hit the backslash. Okay, that gets you or. So the two pipes means or. This is the or operator. And the and operator, both sides needed to be true in order for the whole thing to evaluate to true. How is or different?
At least one of them has to be true for
One side needs to be true for the whole to be true. Yeah, it's a lot more permissive, you could say. It allows for more false values in your, it allows for any false values inside your condition. So this is essentially the opposite of the last one, right? So if I have false or false, I get false. False or true, I get true. True or false, I also get true. True or true, it's true. Did you get that all right? Yeah. Make sense? Can anyone think of a real life condition where it's one or the other that you're checking?
So you could say or has a parent.
What's that?
Like if you have them to do what goes house. If they have I don't have a parent. You do have a parent.
Sure, yeah. So maybe you could say, I mean, let's pretend that our movies, like even babies, can go into it with a parent. I don't know what the actual rules are, but for the sake of our argument, I could say if the person is older than 17, or if the person is 17 or older, or they have a parent with them, you can see in our movie. Okay, that's a good example of an or. If you're 17 or older, it doesn't matter, like if you have a parent or not. Having one true in that or statement is good enough, and the whole thing evaluates to true and you're allowed in. Similarly, if you aren't older than 17, but you do have a parent, one of those two things is true, the whole thing becomes true, and therefore you're allowed in. I think it's like 8 years old. It's like if you're 13 or 8 or something, like it doesn't matter. You can't go into that. But anyway, for the sake of argument, does that make sense? Ors. When I was first starting out, I remember it being kind of confusing to reason about them. But I found that just trying to say it as I would in English, like we just did, makes it a lot easier. So you can determine whether you should use the and or the or. Yeah.
Because I mean, I think it was actually positive. Okay, so what's the truth?
Yep. And yeah, in the end, it's evaluating it down to machine code. Okay, so really quick. There's in the conditionals link that I sent you over Slack, it goes into the order of operations, so you can actually study it if you want. You can use parentheses to group things together. If you have like this or this and this or this, you can group them together with parentheses to ensure that the order of operations happens correctly. We didn't really talk about the not operator, but it just flips something. So if I say exclamation point true, that flips it to false. Say exclamation point false, it flips it to true. What do you think happens if I say, what the heck? Oh, it just let me put this in a full screen thing. That's weird. What if I say like if not true? It's true, right? This, not true, that means false. Not true means true again, right? So not true, I can think like the computer and I can say, well, exclamation point true is false. Exclamation point false is true. So it just keeps flipping. That seems silly, but it is also a technique that people will use to turn now in this case, the computer knows that a non-empty string is truthy, and so it'll work just fine. But it's a way to turn a string into a Boolean, a really tricky, simple way to do so. So this says name is Bob, not exclamation point Bob essentially says, well, the string Bob is evaluated as a truthy value, and then not true, well, not, we already went through this, so not true is true, and it turns it into a Boolean. Don't worry too much about that, but it's kind of tricky just to point out the not operator. And so here's like a fun little exercise we can do. What's that going to be? Okay, why is it going to be false? Because why? Because they're both false. The or means they both have to be false, right? Well, 1 is not greater than 3, so that's false. That's already false, so the whole thing is false. What if I have okay, the whole thing will evaluate to true now. This is still false, obviously, but this is a true statement, and the or means that the whole thing evaluates to true. What about this? Okay, false. Why? Yeah, with and, if either of them is false, the whole thing is false. Okay, beating a dead horse. Those can be kind of fun, but let's do lunch. Not together. I brought my lunch.